Good afternoon, students. Today we'll start Unit 3, Lecture 1, Organic Chemistry, Amino Acids, Peptides and Proteins. In this lecture, we will study preparation of amino acid, deuterion, isoelectric point and electrophoresis. Amino acid. Amino acid contains amino group and carboxylic group on either side of carbon and side chain. So, what is amino acid? The compound having amino group on one side of carbon and other side carboxyl group. Such compound is known as amino acid. On the carbon there is amino acid and carboxylic group on other side, then it is known as amino acid. Amino acids. So amino acids are building blocks of proteins. That means proteins are made of amino acids. It contains a carboxylic acid group and amino group on the alpha carbon atom. So on alpha, next carbon to carboxylic group is known as alpha carbon, and so on alpha carbon you are so contain a carboxylic acid group and amino group on alpha carbon. Have different side groups R that give amino acid unique characteristics. If R is different, then amino acid will have different names. Examples of amino acids: alanine, glycine and lysine. So alanine, you are seeing CH in the place of R, it is CH3 is there, NH2 COH, this is the common. On both sides we are having carboxylic acid and amino, so it is known as amino acid, and in the place of R CH3 is there, then it is known as alanine. So next example is glycine. In the place of R there is H. This is common. Amino and carboxylic group on either side of carbon, that is common, and in the place of R if H is there, then it is known as glycine. Then again next example is lysine. So here also carboxylic group and amino group is there, and on the place of R there are 5 carbons, that is CH2 4 carbon chain is there and NH2 is there, so it is known as lysine. So we are having here lysine is there, CH2 NH2, and on the here NH2 is there and carboxylic acid is there, then it is known as lysine. Aspartic acid. So in aspartic acid, carboxylic group on both sides there is carboxylic group and CH2 is in the middle and amino group on one side and H on the other side of carbon. So here aspartic acid is having 2 carboxylic group and 1 amino group, and in between there is CH2. Then glutamic acid. In glutamic acid, same structure is there, carboxylic acid on both sides, amino group, 1 amino group is there, and but here 2 methylene groups are there, that is CH2 groups are there. So it is glutamic acid, example of amino acid. Next, synthesis of amino acid by Strecker synthesis. In Strecker synthesis, amino acid is prepared by first step formation of amino nitrile. Aldehyde plus ammonium chloride plus sodium cyanide gives amino nitrile. On carbon RH, H2N, NH2CN plus sodium chloride and water. The second step, hydrolysis of amino nitrile to yield amino acid. So amino acid in the presence of HCl, H2 hydrolysis take place and amino acid is formed. So here RCH, NH2, COH. So this is common amino acid, as we know, carboxylic and ammonia group are there, and on C there is RNH is one of the amino acid and ammonium chloride. So by Strecker synthesis, in this way we can prepare amino acid. Next, Gabriel thalamide synthesis. In Gabriel thalamide synthesis, thalamide is there on benzene ring, C double bond O, NH C double bond O is known as thalamide. Then ethanolic KOH is there and potassium thalamide is formed. In the place of HK becomes and you are getting potassium thalamide. Then RX alkylation takes place and in the place of KR is there, so N-alkyl thalamide. So on the NR is substituted, so it is known as N-alkyl thalamide. Then in presence of aqueous HCl and aqueous KOH, we are getting phthalic acid plus RNH2, primary amine and phthalic acid. If you are using hydrazine, then we are getting also primary amine. So in this way, Gabriel thalamide synthesis. Then what is deuterion? It is a dipolar ion, means positive charge and negative charge exist in the same molecule, is known as deuterion. So amino acid is there. So it, if it is acting as deuterion, then NH3 plus CHR and on one of the hydrogen is removed and you are getting O minus. So deuterion. So amino acids deuterion will look in this way. So it is a dipolar, means it is having positive and negative charge on the same molecule, is known as deuterion. So deuterion once more has charge NH3 plus and C carboxylic acid COO minus groups. Forms when both the amino and carboxylic groups in an amino acid ionize in water. So when it is deuterion is formed when both these groups ionize in water, has equal positive and negative charge at the isoelectric point. So at isoelectric point both are having positive and negative charge. So in acidic solution, that means you know that in acidic solution pH is from 7 to 0. So that is at lower pH deuterion mainly exists as cation. Cation means positively charged ion, and in basic solution, that means from 7 to 14 pH, higher pH, they mainly exist as anion, means negative ion. So at higher pH anion they exist as anion, and lower pH they exist as cation, means positively charged, anion means negatively charged. So deuterion acts as anion and cation at different pH. Then what is isoelectric point? The pH of the solution of amino acid at which the acid does not migrate under the influence of an electric field is called isoelectric point of that amino acid. Means at a particular pH the acid does not migrate. Even though it is electric field is passed, the ions do not migrate from positive to negative. So at that pH is known as isoelectric point. So each amino acid has different pH, that is isoelectric point at which the overall charge on an amino acid molecule is 0. That means positive and negative charge are equal, so it is molecule is always 0 at isoelectric point. Examples of isoelectric point. So different amino acid had different isoelectric point. Aspartic acid has 3.0, glycine has 6.1, histidine has 7.6, and arginine has 10.6. So examples of isoelectric point. So different amino acids have different isoelectric point. Then isoelectric point and deuterion, how will you relate it? At isoelectric point an amino acid exists as deuterion. So when amino acid isoelectric point comes, then why it is having 0 charge? Because it is existing as deuterion. So positive and negative charges are there, and so it is having deuterion, and the net charge is 0. The carboxylic group has donated proton with the amino group which form a positive NH3 plus ion is formed. A deuter is a dipolar ion, and both positive and negative charge is different parts of the molecule. So at isoelectric point the molecule exists as, or the amino acid exists as deuter ion. Next, electrophoresis principle. At the isoelectric point the protein does not move in the electric field, but at lower pH than its one protein mainly exists as cation. Lower pH, as we have seen, it will exist as positive and moves towards cathode. Cathode is negatively charged, so cation moves towards cathode. But at higher pH than the isoelectric point, the protein exists as anion and move towards anode. Anode is positively charged, so anion moves towards anode. This movement in an electric field is known as electrophoresis. So this is electrophoresis, movement from the anion moves to anode and cation moves to cathode. This is known as electrophoresis, and methods based on this principle has been developed for the separation of protein. This principle is used in the separation of proteins. Then electrophoresis is the most common electrokinetic phenomena. Means kinetic means motion, electrokinetic means motion phenomena is there. It refers to the motion of charged particles related to the fluid under the influence of an applied magnetic electric field. So when electric field is passed, positive ions moves toward cathode and negative charge move towards anode, and this is electrophoresis. If an electric potential is applied to the colloid, the charged colloidal particle move toward the oppositely charged electrode. So this is, you know that negative will move towards anode and positive will move towards cathode in electrophoresis. So here this is the diagram showing electrophoresis. So in this way positive and negative ions are there, and so the colloidal solution is taken and electricity is passed, and negatively charged moves towards anode and positively charged moves towards cathode. Thank you.